Okay, so this evening we're going to shift our discussion to the remaining vectors. In this case, we're going to talk about b minus a. So we saw that the vector b minus a along the x direction has got a size of minus 29 meters. So b minus a along the x direction has the size of minus 29 meters, and along the y direction, b minus a has got a size of 12 meters. So along the x-axis is negative, meaning that it is pointing in the negative part of the x-axis. So that's where b minus a x is pointing. So b minus a x is pointing in that direction. Then b minus a y is pointing north. So if we do a sketch of these two vectors, before we do that, we can find the size. What is the magnitude? Like for any vector, you have to find the magnitude, and later on we can move on to the direction. So we know that b minus a along the x direction is minus 29 meters, and along the y direction is 12 meters. So what is the size of b minus a? So the magnitude of b minus a, so magnitude, we write magnitude like that of b minus a is going to be equal to the square root of bx minus ax. Bx minus ax is how much b minus a is along the x-axis squared plus by minus ay. That is how much b minus a is along the y-axis squared. So bx minus ax along is 29 meters, minus 29 meters, and by minus ay is 12 meters. So we square that, we end up with 985. Then the square root of this gives us 31.4 meters. This 31.4 meters for b minus a, the size b minus a equals to 31.4 meters, is the same as the size for a minus b. For a minus b, if you recall very well, for a minus b we found 31.4 meters. So what is the difference here? So we have found the size of b minus a, it's 31.4 meters. So the conclusion you draw here, if you put two vectors, you have got a minus b and b minus a, the size is the same. What direction is b minus a pointing in? So we have the x component of b minus a being minus 29 meters, that is pointing along the negative x-axis, and b minus a along the y component is 12 meters, it's pointing along the positive y-axis. And when you do that, we end up with this. So the red line here, lying along the negative x-axis, this red line is our bx minus ax, that is equal to negative 29 meters. Then the other red line lying along the y-axis in the positive direction, that is by minus ay, which is equal to 12 meters. Like we did before, we shift this y component of b minus a, then we come and put it at the end of b minus ax. So we move along the x-axis, bx minus ax, we move along the x-axis minus 29 meters, then we move along the y-axis, by minus ay, 12 meters. We have not done anything different here. The only thing we have done is we have shifted the y component. As long the y component and the x component are vectors, so as long as the size is still 12 meters, and when we do the shift, it is still parallel to the y-axis, the direction has not changed. So when we move along the x components of b minus a, and we move along the y component of b minus a, we end at this point. We end up at this point. That point is, we can also end up at that point by moving along this green line here. This green line is the resultant b minus a. So that is what b minus a is, this green line here. It's a resultant b minus a. And we have found that b minus a is actually 31.4 meters. So the next thing we need to do, we have a general location. It is somewhere in the second quadrant. Okay? So we need to find a precise direction in terms of an angle from the positive x-axis, and the angle we are looking for is theta, this theta which has been shown here. However, as we have seen before, when you are in the second quadrant, it is not possible for you to directly get theta from your components. What instead we do is that we work out this angle inside this triangle. So if you look at the x component, that is minus 29, then the y component, which is 12 meters, then the vector itself, b minus a, that can act as a hypotenuse. We have a triangle here. And angles, in this case, the angle of the triangle, like I think I've mentioned this before, the angle, the x, this angle theta outside the triangle is always measured from the x-axis, positive x-axis, in an anti-clockwise direction like this. However, this angle theta, this angle phi inside the triangle can be measured from the positive x-axis, or it can be measured from the negative x-axis, depending on where the vector is. So in our case, this angle phi is measured from this negative x-axis, then we move in that direction, clockwise. So since we are moving in a clockwise direction, you expect this angle phi to come out negative. The other thing to note is that if you add theta plus phi, you should end up with 180 degrees. So we're going to use this relationship that if to the x-axis, negative x-axis, the negative x-axis, we move backwards clockwise, meaning clockwise, by adding theta, we're going to end up with phi. So we're going to use this relationship. So the thing we do right now is we're going to try to work out this angle inside this triangle, this angle phi. After we work out this angle phi inside this triangle, by using the adjacent, which is minus 29 meters, and the opposite, which is 12 meters, we find this phi. We are going to add this phi to 180 degrees. The reason why we are doing that is because phi is measured from the negative x-axis in an anti-clockwise direction, in a clockwise direction. So it's negative, so 180 degrees plus a negative angle should give us theta. Are we clear on the logic we are doing here?
Can you repeat it?
Huh?
I would just like you to repeat it.
Which part am I repeating?
The one where you subtract the theta, the x, make the angle x there, where you said you have to subtract.
This angle here, theta, you see this angle theta? The x-axis, from the positive x-axis to the negative x-axis, you see this line?
Yes, sir.
This is 180 degrees. Are we clear?
Yes, sir.
This is 180 degrees.
Yes, sir.
Yes. So, what I'm trying to show here is that phi and theta are related. Phi and theta are related because phi plus theta gives you 180 degrees if our angles did not have directions. The reason here, the difference is, if we're just saying angles, okay, would have said theta plus phi is equal to 180 degrees. That's fine. The problem here is that we have decided to say in this course, the angle theta, which is what gives you the direction of the vector from the x-axis, the positive x-axis, is going to be measured in a anti-clockwise direction, and in this anti-clockwise direction, the angle is going to be positive. Are we clear? This theta, it's measured in an anti-clockwise direction like this, and we take it to be positive. Any angle measured in a clockwise direction is taken to be negative. Is that clear?
Alright, sir, now clear.
Yes. So this angle phi here, this angle phi which is here, will be measured from this negative x-axis. This negative x-axis is 180 degrees, but this angle phi will be measured in this direction, clockwise direction. So basically what you're going to be doing for you to get theta, because there is a thing of direction, you need to add to the 180 degrees, you add phi, then you get theta. As we are going to see when we work out phi, phi is going to come out negative. because we are using this relationship, the opposite divided by the adjacent, that is the tangent of this phi. If the opposite is 12 meters, the adjacent is minus 29 meters, then we expect this angle phi to come out negative. And that's what we do here. We work out tan phi. Tan phi is equals to by minus ay divided by bx minus ax. So by minus ay, that is 12 meters, bx minus ax, that is minus 29 meters. So you go 12 meters divided by minus 29 meters on top, and this gives us minus 0.41.
Sir, is it recorded?
Yes, it's being recorded. Everything is recorded. You want to leave the class?
No.
Okay, now we have recordings which we post in your things. We post the video to YouTube, then later on we post the link from YouTube, we put it in your Moodle. So you go on your Moodles under this topic, you should find recordings there. Okay, so this one is also being recorded. So tan phi is equals to minus 0.41. Then you work out phi. Phi is going to be equal to the tangent, arctangent, the tan inverse of 0.41, and that gives you a phi of minus 22.3 degrees. This is your phi. So what are we saying here? We are measuring this negative. It's negative 22. The reason why it's negative is because the angle is being measured in a clockwise direction. Clockwise from which direction? Always angles are measured from the x-axis. Phi can be measured from the negative x-axis or from the positive x-axis. In this case, we are measuring the angle phi from the negative x-axis in a clockwise direction. We're going opposite what we have agreed upon for angles is supposed to be the positive direction, because the positive direction for angles is the anti-clockwise direction. And in this case, this angle is negative. So 180 plus whatever this angle is should give us theta. And that's what we proceed to do. So we say theta is going to be equal to 180 degrees plus phi. If phi was positive, then it would be 180 degrees plus a positive angle. But in this case, phi is negative, so we're going to get 180 degrees plus minus 22.3 degrees. And we get theta equals to 157.7 degrees. So B minus A has a size of 31.4 meters, and it makes an angle theta of 157.7 degrees from the positive x-axis measured in an anti-clockwise direction. So we have a precise size and a precise angle. Is this clear?
Yes, sir, it is.
Okay.
Yes, sir, it's clear.
Good. Next, we said that you are not restricted to adding or subtracting only two vectors. You can add as many vectors as you want. So here we have got A plus B plus C as an example of us carrying out addition of more than two vectors. So in the case of A plus B plus C, along the x-axis, A plus B plus C has a size of minus 11 meters along the x-axis, meaning that it is pointing along the negative x-axis. Then A plus B plus C along the y-axis has a size of 40 meters. AY plus BY plus CY has a size of 40 meters. So from this information, how much A plus B plus C is along the x-axis, minus 11 meters, and how much A plus B plus C is along the y-axis, minus 40 meters, we can find the size of A plus B plus C by using the same Pythagoras formula. And this is why we do it. So the magnitude of A plus B plus C, written like this. So this is magnitude of A plus B plus C is going to be because the square root of A plus B plus AX plus BX plus CX squared plus AY plus BY plus CY squared. That is, this is the size of A plus B plus C along the x-axis. This is the size of A plus B plus C along the y-axis. And we have seen from the table, it's minus 11 meters. Then along the y-axis is 40 meters. So you work out this, you end up with 1,721 meters squared. Then you do the square root. You get a size for A plus B plus C, which is approximately equals to 41.5 meters. That is the size of A plus B plus C. That's just one part of the puzzle, because as I've been saying, vectors have got magnitude and they also have direction. What is the direction? So when it comes to A plus B plus C, along the x-axis, as you have seen from the table, along the x-axis is minus 11 meters. Minus meaning that the x part, the x component, is pointing in the negative x-axis and the y component is pointing in the positive x-axis. So when you draw that, those components here, ax, the x component of A plus B plus C is minus 11 meters. It's this red line down here. It's pointing in the negative x-axis. And the y component is this red line here also. AY plus BY plus CY is 40 meters and it's pointing in the positive y-axis. We get this y component, we shift it, we put it at the end of the x component here, so that we move along the x component minus 11 meters along the negative x-axis. Then we move 40 meters along the y component parallel to the y-axis, and we end up here. When we end up here, it's the same as moving from here along the green line there. This green line is your A plus B plus C, your resultant. And we have just found the size of this thing, the resultant, somewhere 41.5, whatever it is. But that's the size. So the size has been found. The next thing is the direction. Again, direction, when you're talking about direction, you're talking about the angle theta, and this theta is measured from the positive x-axis in an anti-clockwise direction. We consider the anti-clockwise direction to be the positive angles, the clockwise direction to be negative angles. However, as you can see, using the information we have, it is not possible for us to find theta by using just the x components and the y components. However, if you look at the x component and the y component and the resultant, you notice that we have a triangle here. And this triangle has got an angle inside, which is phi, measured from the negative x-axis here. So we can work out this phi using the x component and the y component, find the phi, then we add it to 180 degrees. Again, the phi is based on the y component, which is 40 meters, and the x component, which is minus 11 meters. So this phi is going to come out negative. Are we clear?
Yes, sir.
Okay, so we're going to make progress. So we work out phi. So this time tan phi is going to be equals to the y component of A plus B plus C, which is this one, divided by the x component of A plus B plus C, which is that one. So the y component is 40 meters divided by the x component, which is minus 11 meters, and that gives us minus 3.64. This. Then, so that's tan phi is equals to minus 3.64. Then phi is going to be equals to the arctangent of minus 3.64, and that gives us phi, which is equals to minus 74.6. You can see the minus there. The minus is telling you that the angle is being measured in a clockwise direction. Clockwise from where? Clockwise from the x-axis, the negative x-axis here. Phi is being measured clockwise from the negative x-axis. So if you go in the clockwise direction, then the angle is negative. So we are adding this angle phi, we're measuring it from the negative x-axis. The negative x-axis has an angle of 180 degrees. So 180 degrees plus whatever phi is should give us theta. So in our case, so that's what we're doing here. So theta is going to be equal to 180 degrees plus phi, but phi is negative 74.6. So 180 degrees plus negative 74.6, and that gives us theta equals to 105.4 degrees. Is this clear?
Yes, sir, it is.
Yes, it's clear.
It's clear now.
If an angle or if a vector is in the third quadrant here, your phi will come out positive. If your vector is in the third quadrant, your phi will come out positive. So you will add 180 degrees plus a positive phi. That will give you an angle theta which is greater than 180 degrees. Are we clear? So in the third quadrant, your phi is positive. In your second quadrant, your phi is negative. In your fourth quadrant, your phi is negative. In the first quadrant, your phi is positive. But in the fourth quadrant, something also happens, which is what we're going to look at. So we move on to this one. A plus B minus C. AX plus BX minus CX, that's 9 meters. Then AY plus BY minus CY, that's 40 meters. So in this case, both components are positive. So the x component of A plus B plus C minus C is pointing in the positive x-axis and has got a size of 9 meters. Then the y component of A plus B minus C is also pointing in the positive y-axis and has a size of 40 meters. So from these components, 9 meters for the x component and 40 meters for the y component, we can get the size of A plus B minus C. We can work out the size. Here, the size of A plus B minus C is going to be the square root of the x component of A plus B minus C plus squared plus the y component of A plus B minus C squared. So the x component is 9 meters plus the y component, which is 40 meters. Like that. You add these, you end up with 1,680 under the square root, then you square that, you end up with 41 meters. So the size of A plus B minus C is 41 meters. When you plot these components on the x and y planes, the x component of A plus B minus C, 9 meters along the x-axis and 40 meters along the y-axis. When you do that plot, what you end up with is this. AX plus BX minus CX, 9 meters along the x-axis. So if it's positive, the x component is positive, it lies along the x-axis like this, pointing in this direction. Then the y component, AY plus BY minus CY, it's positive, so it lies along that direction, like that. Okay, just a minute, I almost forgot something I'm supposed to do. Yeah, I'm supposed to do voter verification. So I've been forgetting my voter's card. Okay. Like that. So we have the x component, 9 meters positive. You've got the y component, 40 meters positive. Again, we pick the y component, we plant it at the end of the x component so that we move like this. Okay, along the x component, then we move up like along the y component, then we find ourselves there. There where we found ourselves is the same as moving from here, the origin, moving along this green line, and this is your A plus B minus C. A plus B minus C, this green line. Okay. Are we clear on that? On where we think...
Yes, now we are clear.
Yes. Now, I want to explain a couple of things here. 2 things about the angles. As you can see, the only angle you can see here is theta. What has happened to the phi? Somehow the phi is not here. what has happened to the phi? Theta, by definition, is the angle from the positive x-axis moving in an anti-clockwise direction up to where the vector is. That is your theta. That's what theta is, measured in an anti-clockwise direction like this. Phi, on the other hand, is if you look at the x component, this red line, then you look at the dotted line here, the y component, then you look at the green line here, you realize that you have a triangle. This triangle needs to have an angle of the triangle, which is phi. So in this case, the angle of the triangle phi is the same as theta. Are we clear? Is that clear? Is it obvious that the angle, this angle of the triangle, this angle of the triangle phi is the same as theta? Is that clear?
Yes, that's clear.
Yes. So, when your vector is in the first quadrant, you can work out phi, but phi is going to be measured from here. You're going to measure phi from here. And this direction here, this is 0 degrees. So 0 degrees plus phi is going to give you theta. Is that clear? 0 degrees plus phi is going to give you theta. So whatever phi is, when you work out phi, then you add 0 degrees to it, that's what's going to be theta, right? So basically, theta and phi in the first quadrant, they are the same. Are we clear on this information that theta and phi in the first quadrant are the same? Therefore, we do not work out phi. We just straight away work out theta. In this case, we work out tan theta is equals to the y component divided by the x component. The y component is 40 meters divided by 9 meters. That gives you 4.44. Then theta is going to, because the tan inverse of 4.44, and that gives you an angle theta which is equals to 77.3 degrees. This 77.3 degrees, if you could have used phi, you get 77.3 degrees. Then you would have to add 0 plus phi will give you theta. So theta would be equals to 0 degrees plus phi. That is to give you 77.3 degrees. Are we clear?
Sorry, question.
Yes. What is your question?
Why are all
What?
why do the triangles face any direction?
What is what? Why is what?
Triangles face any direction? Or
Can you repeat your question?
I'm saying triangles, they follow quadrants or not?
Do they follow quadrants? I don't understand your question. Any other question? Do you have any other questions? If you don't have questions, we have to come to the end. Okay, if there are no other questions, we'll come to the end. So we are done with vectors and scalars. So the next time we meet, which is, I think, when? Tomorrow? Or Wednesday? Yeah? Which day is it we're meeting?
All right, okay.
Tomorrow at what time?
Tomorrow, 12.
Yeah, at 12:30, we're going to start looking at motion. Description of motion. Yeah. So I'll see you tomorrow. Unless people have got questions, I'll stop the recording now.
Sir,
Yes.
the question, sir. What time will be the test on the quiz on Monday?
You can do the quiz anytime. But there has been a problem. There was a problem last year, and the problem was other students, because students don't change their computer numbers. The computer number is the same, but it turns out that somehow your friends would get your email address because you have not changed the password to your Moodle. They would access, because your computer number is a default password for your Moodle. They would access your Moodle. Then they would take the quiz on your behalf. So they would see the questions. Then after that, they would take the quiz later on during the day. So crafty students would do this, and until they were sure about the answers, then they would take the quiz on their own. So my advice is, if your password to Moodle is still your computer number, you're at risk. Change that password so that people can't take the quiz on your behalf. The quiz should be able to open, I think, at 8 hours, go all the way up to for 24 hours, I think. But you're going to take, when you decide to take the quiz, it will last for 30 minutes. But you can take the quiz, I think, anytime within 24 hours from the time it starts.
So the quiz will be on the 7th of April?
I don't know, Anga. What does it say on anything? I don't know what it says, but yeah, someone is going to set up the quiz for you.
We received the notification on Moodle to say that the quiz is on the 7th of April.
When is 7th of April? 7th of April. That looks like April 7th. That looks like Wednesday next week. Yeah, Wednesday next week. Yeah, so during that Wednesday, anytime during the day, you can take the quiz. You just log into your Moodle, then you answer a couple of questions, multiple choice questions. Then when you're done. Then at the end of the day, you'll receive a result. Is that clear?
Yes, sir.
Yeah. So please, as soon as possible, take the quiz. The other thing is change your password. Because when you come crying to us that someone has answered the quiz on your behalf, there's nothing you're going to do. You are supposed to change your password to something which your friends do not know, and do not share your password with your friends. Are we clear?
Sir.
Yes.
Yes. Sir, I was kind of asking on the same question about FITA on the first quadrant there. Is it right to write three numbers like 0, 77 degrees Celsius?
What?
Like on that same number where you write FITA is equal to 0 plus that other number.
Fee.
Is it possible to write three numbers or is it write two numbers?
What do you mean is it possible to write three numbers or write two numbers?
Like in degrees. Are you supposed to write 77 degrees or 0.77 degrees?
It doesn't really matter. Why do you want to write 0.77 degrees as if you don't come from Earth?
Because like what happened in chemistry, we found that you were supposed to land off something then.
Whatever happens in chemistry is in chemistry, my friend.
Right.
Yeah. Okay. Are there any other questions? All right, if there are no questions, we come to the end of our class. Thank you very much for attending. We encourage you to continue attending and asking questions. Okay. Yeah, the next topic is going to be something to do with motion. We'll start looking at things like displacement, velocity, acceleration, equation of motions, projectiles, and stuff like that. All right, so we stop sharing. I'll stop the recording.